Okay, this is section 3.1, titled Sets and the Real Number. That's chapter R, section 1. All right, we start with the definition of absolute value. Letter A is the definition, and it says, let x be a real number, then the absolute value of x is x if x is greater than or equal to 0, or the opposite of x, or negative x, if x is less than 0. Letter B gives us a verbal description, and it says, number 1, if x is positive or 0, then the absolute value of x is x itself. As in, if x is 5, then the absolute value of 5 is just 5 itself. Number 2 says, if x is negative, then the absolute value of x is the opposite of x. As in, if x is negative 3, then the absolute value of negative 3 is the opposite of negative 3, which is 3. All right. Letter C is examples. We'll skip over 1 and 2 because those are there's not really any work to do. But you know what? Let me read through them. So the absolute value of 2 is 2. That's example 1. And then example 2 says the absolute value of negative 2 is the opposite of negative 2, which is 2 again. All right. Let's try number 3. Rewrite the following expressions without absolute value bars. There's A, B, and C. We'll do A and B, and then we'll leave C to discuss in class. So letter A says the absolute value of x minus 5 for x is greater than or equal to 5. And so what does it mean to write without absolute value bars? Well, it really means to write an equivalent expression, or an expression that will give us the same answer as the absolute value of x minus 5 whenever x is greater than or equal to 5. And to do that, we need to just analyze. And let's plug in some numbers that are greater than or equal to 5. So if x is 5, we start with that one, then the absolute value of x minus 5 is the absolute value of 5 minus 5, which is the absolute value of 0, which is 0. If x is 6, then the absolute value of x minus 5 is the absolute value of 6 minus 5, which is 1, and the absolute value of 1 is 1. If x is, let's say, 12, then the absolute value of x minus 5 is the absolute value of 12 minus 5, which is the absolute value of 7, which is 7. And notice that for each one of those values that we've picked, when we take it through all the steps of the absolute value and such, it just ends up giving us the same thing as x minus 5, right? The expression that we're given is the absolute value of x minus 5, but if we just do x minus 5, that gives us the answer already. And so, for x greater than or equal to 5, the absolute value of x minus 5 can just be replaced with x minus 5. Okay? Again, this is for x greater than or equal to 5. Yeah? All right, so I'm going to say that's our answer. All right. So the absolute value of x minus 5 for x greater than or equal to 5 can be replaced with x minus 5 for x greater than or equal to 5. Let's try B, the absolute value of x minus 5 for x less than 5. And again, we plug in some values. So let's plug in like 4. And so this would be the absolute value of 4 minus 5, which is absolute value of negative 1, which is 1. Let's try, let's go a little smaller, closer to 0, like a 1. So the absolute value of 1 minus 5 is the absolute value of negative 4, which is 4. Let's try 0. So the absolute value of 0 minus 5 is the absolute value of negative 5, which is 5. Okay, and let's try a negative, like negative 2. The absolute value of negative 2 minus 5 is the absolute value of negative 7, which is 7. I don't know if you're seeing this, but if we write the expression 5 minus x, and just plug in each of those numbers that we just tried, when we plug in 4, the absolute value of x minus 5 gave us the answer 1. And if we do 5 minus 4, we also get the answer 1. That is, if we do 5 minus x without absolute values. If we try using the absolute values, we tried 0, right? So absolute value of 0 minus 5 is the absolute value of negative 5, which is 5. If we write the expression 5 minus x instead, 5 minus 0 is 5 also. Okay? And we try negative 2 the way we did, which, if you remember, negative 2 was the absolute value of negative 2 minus 5, which is the absolute value of negative 7, which is 7. And if we try 5 minus negative 2, it also gives us 7. So an equivalent expression in this case would be 5 minus x for x less than 5. Notice what we've done. So in this case, if you look up here for the at the absolute value of x, at the definition at the very top of the page, it said the absolute value of x is x if x is greater than or equal to 0, or negative x if x is greater than 0. And so what we've determined in parts A and B together is that the absolute value of x minus 5 is x minus 5 for x greater than or equal to 5, and 5 minus x where x is less than 5 from part B. All right, so I'm going to leave it there. That gives you kind of an idea of what sorts of things you're going to do. Notice it takes a lot of analyzing and maybe checking out some numbers. We'd be able to see this maybe in a graph, and we'll check that in class to see if we can check a graph. And letter C, I'm going to leave it for a discussion in class. Let's go on to part 2, write algebraic models. So the first thing says, I'm going to skip over part A. It just says that a verbal description gives us can be written down in an algebraic model, or it seeks to do that. All right. So letter B, an example: a moving company rents a truck for $19.95 and charges 36 cents per mile. Write a formula that gives the cost C of using the truck for X days and Y miles. I'm going to backtrack a little bit and make the assumption that the $19.95 is per day. So I'm going to add that in there, $19.95 per day. All right, and then 36 cents per mile. All right, so we're going to write the cost. So the cost is $19.95 times the number of days X plus 0.36 times the number of miles Y. And notice we have to use 0.36 because we're writing these in dollars. And we wrote the first expression in dollars, 19.95x. All right, and that'll be our answer right there. That wasn't too much. Okay, let's go on to part 3, simplifying algebraic expressions. Letter A says to evaluate means to substitute known values of the variable or variables and simplify. Letter B, to simplify, we use the rules for order of operations. And then letter C, some examples, evaluate each expression for the given values of the variables. We'll try example 1. There's 2. We'll leave 2 for the example 2 for class. Example 1 says the fraction 2 minus x over y. So the numerator is 2 minus x, denominator is y. For x equals negative 1, y equals negative 12. Then I'm just going to plug in those numbers. So my expression will be 2 minus negative 1 over negative 12. And then I'm just going to simplify that, so that'll be 3 over negative 12, which is negative 1/4. And that's my answer. Okay? And we'll leave 2 for discussion in class. All right, I'm going to skip on over. You know what, I'm not. I think I'm going to go ahead and stop the video here and for R2, start another video.